So let's just start. It said 3 o'clock in the program, but later on it said 15 minutes later. But well, the room is pretty much filled. So, my name is Lengkeek. I'm a software consultant at Luminis Rotterdam, and I mainly work with Java EE applications. And the last couple of years before I joined Luminis, I mainly worked with a bit of legacy applications. And when I had to find something to write my thesis about, I decided to choose something flashy and new, and that's HTTP2, and specifically about server push. I will be telling you more about server push, of course, later on. In my free time, I'm really into do-it-yourself home renovation. I recently bought a house, and when there's time left after that, usually not much. I love listening to music, and I like to go camping in a small tent, traveling around. So HTTP2, as you may have already guessed, this talk is going to be about HTTP2. And thank you all for coming. And I think it's a wise choice as well. Of course I do. But also because HTTP2 is not coming, it is already here yet. It has been released back in, the specification is approved already back in 2015. And more websites are using this protocol. First of all, before I'm going to tell you what I will talk about, I'd like to show you an example. It's an image, and it's the same image twice, and it's cut up into 180 smaller images. And the left one will be loaded over HTTP1, and the right one over HTTP2. So here it goes. This is HTTP1, and this is HTTP2. If all is well, you may have noticed a slight difference. So, just to get an idea, well, I'm going to tell you about HTTP1 first. Then I will introduce HTTP2 to you and its main new features that I think is interesting, that I think that you will be hearing more about in the future. I will give you some examples as well, with some code and also in the browser. Then you may be wondering, maybe even now, what does that mean for me? I think most of you are developers, and if not, it doesn't matter. But what is in it for you? I will give you some ideas that you should think about when you want to play around with HTTP2. So first of all, HTTP1. Most of you know HTTP1 because it has been around for 20 years now. It was introduced in the mid-90s. Just to help you remember, because it may be hard to remember that back then we were happy with Netscape or the new Internet Explorer 3. And we were even excited about the occasional newsletter we received through our hotmail.com account, and we would actually read all the newsletters we received and so on. Well, how things have changed. And the internet has changed as well. Back then, the average web page used to be 15 kilobytes in size. Last year, the average web page reached the same size as the original Doom game, which is about 2.4 megabytes in size. This is 160 times as big, and when you would still have a 56K connection today, I hope not, it would take 8 minutes to load such a page. Do we really need pages the size of, well, around 1.5 floppy disks just to stay in the whole 90s? Well, yes, it's inevitable. We have web shops now. We do all sorts of business over the internet. We have multimedia, we have advertising. And it needs to be fast too. Half of the users expect a page to load within 2 seconds. And if it takes longer than 3 seconds to load, they may even, well, they are very likely to leave your page and never come back. and they will never do what you want them to do, buy your product or read the important information you have on your website. And the HTTP1 protocol was, of course, not designed with this in mind. And in 1997, they did an upgrade to HTTP 1.1, where, amongst other things, you could keep the connection open for some time. And also, during the past few years, there has been additional experimentation to further improve the HTTP protocol. Maybe you've heard about Speedy, that is from Google. And eventually, all these experiences and experimentations were standardized in the new HTTP 2 protocol specification released in 2015. Well, what about HTTP 2? That's what you're here for, right? I will go over the main features. I will tell you about multiplexing. I will tell you more about the fact that it's a binary protocol, that it uses header compression, and that there's a new option, server push, I already mentioned it, and stream prioritization, a real tongue twister. First of all, multiplexing. HTTP1 is sequential. It looks something like this. To the left, you have, well, a client, a browser, and to the right, you have the server, and this is about one connection. Well, let's say you would like to go to google.com or something, or devcon.com, EU, I don't know. And, well, you request to the server, give me the HTML file. And then you will have to wait for the response of the server, and then you will receive the HTML file. And then the browser starts to parse the HTML tags. And it will find out that it needs additional resources which are referenced from the HTML, such as a JavaScript. And it will send a request to the server for that file. And then the server will respond with a JavaScript file. But in the meantime, the browser already knew with the parsing that it also needed a CSS file. But it had to wait for the whole first operation to complete before it could send another resource to the server for the CSS file as well. And then here the file comes in. And this could go on for some time until all the resources for the page are loaded. This is the case with one connection. On top, you can see that HTTP1, you can have 4 to 8 of these connections at the same time over one domain. So it actually goes a bit faster than that, but there's still a limitation, and it's still sequential. With HTTP2, you would only need one connection for all these operations. And it would look something like this. The same situation as before, but now you have, well, a beautiful HTTP2 enabled browser. Most browsers support HTTP2 already, by the way. And also the server. We want the HTML, please give us the HTML, here it is. And when parsing, immediately when the browser finds out that it needs the additional resources, it sends the request for these resources. And it doesn't have to wait for the response from the server to come back before it can post another request on the line. And also the server may choose when to respond. For example, maybe it feels like sending the CSS first for whatever reason, and that's perfectly fine. And then the JavaScript. So that's multiplexing. I would like to show you an example. And then I also have an opportunity to show you a tool in the Chrome browser that I love to use. So this is just, well, a basic Maven web project in Eclipse. And here I have my web app, and I have 15 images. I have an index, and I have 2 CSS files, and I have 1 JavaScript file. And in the index, all these files are referenced. Here are both the CSS files and all the 15 images, and then here the JavaScript. And here's some bulk that is just for demonstration purposes so that it doesn't load too fast locally. So I created this web app with Jetty. It's an open source Java web server. More about that later, why I chose that. So let's deploy this, and I created a script for this because for my thesis I had to do this 100 times a day, so it's really nothing special. So here's the website. It's not interesting at all, but here you see the images scrolling with help of the JavaScript. What is interesting is Chrome's developer tools. And you can find them. I think there's also a function key for it, but here you can right click and you go to inspect. And maybe you notice few, but for me right now the most interesting one is the network tab. And it's actually recording, so let me refresh the page. So what you see here is, well, Chrome is a bit here you see all the resources I showed you in Eclipse. They are here. And then to the here, this column, you will see the protocol which is used. And we see that all the resources have been sent over HTTP2. Well, that's good. Type and the size are not that interesting. And by default, this column is hidden. And you can right click and you can select all sorts of other interesting columns with additional information. And here is the resource waterfall chart. Here you can see the sequence of all the resources which were loaded from left to right. Left is 0 in time, and to the right it's later. So first you see that the index here was requested. Maybe I better use the laser pointer because this is a bit annoying, maybe. So just slightly above my cursor. The index is requested, and you see the white and the gray part is the whole requesting action. And the blue and the green part is the actual downloading. And you see that after it's requested, it'll mainly only focus at the index at the beginning, and then it will start to download the index. And that's also why I put a lot of bulk here, so that it doesn't go that fast. And I didn't feel like using network throttling. So here, after the index is downloaded, there's a bit of a time frame because the browser is parsing the text. And then it finds out, well, I need a CSS and I need JavaScript and I need all 15 images. And then it will start to put out the request for those as well. And here you can see as well that multiple requests are outstanding before the response, the actual downloading of the resource has started yet. So a lot of resources are outstanding. So that will also give you an idea. And here you can, on top, you can also see that it's just one continuous line, which means that it's one connection and not multiple. So you can do all these operations over one TCP connection. Yes. Then HTTP2 is a binary protocol. The frames are not, the frames from HTTP1 were in fact human readable. If you've ever debugged HTTP traffic, then you know that. But HTTP2 frames are no longer human readable. You won't be able to read them unless you are some cyborg. I haven't spotted any here. So you won't be able to read them. And they're a binary because they are more efficient to parse and they require less bandwidth on the line. It's just more efficient. And if you come to think about it, isn't it even strange to begin with that the HTTP1 protocol had human readable frames while the computers had to do most of the work? So HTTP2 is a binary protocol. Then HTTP uses header compression. It compresses the headers of the HTTP messages. Well, let's take a look at a header. An HTTP message consists of a header and a body. And a header has, multiple fields with values. And for example, it holds information about the cookies, about the language, about the accepted character set, and for example, the date. So it's actually information about the information. And the body just, surprise, contains the actual data, the HTML or the image, whatever. So for example, like this, you have all kinds of fields. And then you have, here, for example, some very interesting HTML. That's what, that's mainly roughly what a HTTP message looks like, really simplified. And during a session, many of these messages may be sent back and forth over the line. And some fields of the header, most fields and also the values are not very likely to change. But despite that, they are sent over the line every time. So only part of the bandwidth is used for actual communication. That's, you have that with a protocol. But it's a bit unnecessary if you send the same data over and over and over and over again. So what HTTP2 does is it still sends the header because you still need the header information. But HTTP2 compresses the headers and it uses HPAC compression to do so. So here we have another example of an HTTP header. And with the HPAC compression, each end of the line maintains a table, one static table and one dynamic table. And the tables contain a number and also a phrase with a field and a value. And the static table is defined by the protocol. These are, sort of standard phrases that every HTTP connection uses. And in a dynamic table, the dynamic table is empty at the start of the communication, but it will be filled later on with exchanged values. And this is what an encoded header would look like. And just for comparison, just an example, on the left side you would need 59 characters to describe the header, and on the right, 6. So both ends of the line maintain the same table. Then you have stream prioritization. And first, let me explain a bit about what is a stream. A stream is a new concept in HTTP2, and it's officially a bidirectional sequence of frames over one connection, and they share a stream ID. So here I drew 2 streams, but it could be lots more. And there's one connection between a client and a server. We have, at the same time, we could have information going from the client to the server. and back. And you can have lots of streams on one connection, and this is also for the multiplexing. These streams can be sort of interleaved to create efficient communication. And with stream prioritization, the client can actually assign a weight to a certain stream. It could be a number, an integer between 1 and 256, and it gives a weight to a stream. So for example, if the client thinks that stream 1 is more important, it tells the server about that, and the server can react and can also give priority over the responses from the server to the client over that stream. So why would you use stream prioritization? Well, for example, it can be helpful to give priority to streams which handle certain types of resources. For example, modern web pages tend to load graphical data fast for the users to perceive the page as fast loading. But in the background, all sorts of other things may be loaded, for example, advertising. And stream prioritization can actually help with that, so that you can give priority over the most important components to load first. Just an example. Then HTTP2 has the option for server push. And it has nothing to do with push messages as you know of, or violence. It basically just allows the server to send resources in advance, to push resources to the client. And when the client receives an HTML page, it starts to parse the HTML tags. And then, as seen before, it's likely that it discovers that it needs additional resources. And then for each of these additional resources, the client needs to send an additional request to the server. It has to wait for the response to arrive so that it can further render the page. But with server push, the server somehow knows what the client is going to request next, what the client is going to need next. And it can preemptively send these files to a reserved part in the browser's cache. And this saves round trips. It'll actually, in total, saves requests on the line for a whole page to load. Let me show it to you graphically once again. So we have server push enabled client and the server push enabled HTTP2 server. And we want an HTML file. We would like to load a web page. And then we get the HTML. And before the client even has the opportunity to see that it needs additional files and to request these files, the server already knows this, and it already preemptively pushes these resources to the client. So when the client starts to parse the HTML tags and it finds out, wow, I need a CSS file, it's already there in its cache. I would like to show you an example of that as well. And as said before, I chose Jetty server to do this because Jetty has its own server push logic you can use, but it also allows you to implement your own server push logic. So let's go back to the same web app. I've changed nothing here. What I did do is I created a Java servlet filter, just as you would define any servlet filter. Let me enable this. Oh. I've been developing more on Windows machines recently, so. So here, this is just a basic filter, and I have pointed it to my own filter class, and also, well, filter mapping. Here I have implemented the Java Servlet filter class. And in the do filter, it's really simple. What I did is I used the Jetty push builder. And what I basically just did is, well, give a path to the push builder and say to the push builder, well, if you continue with this request, also after that, push these resources. And of course, you can think of all smart algorithms to decide what to push and what not to push. Here, for demonstration purposes, I just said just push these two CSS files. As we've seen, they're here. So let's, did I save this? Yes, I did. Else it would be an unpleasant surprise. So let's redeploy this. Yes. And let's reload the page, and I will keep this tab open because, well, the web page hasn't changed at all. Yes. So here we still have the same resources. We're still using the HTTP2 protocol. And what else is interesting is that, and I'm sure that this column is hidden by default, just right click and then you can see, you can make the initiator column visible. And here you can actually see how the browser received that particular resource. And here you see that these two resources, the CSS files, were actually pushed. And they were pushed in a reaction to the request of the index HTML file. And the rest is just regular index, it's not pushed. You can also see it to the right here. Also note that there's some overhead because you need a secure connection. More on that later. That costs a little bit of time when you set up an initial connection. But here still we request the index and we download it. And even before it's fully downloaded and before the browser has had a chance to see what is in the index file, the push action already starts. The dark blue is the downloading, remember, and here the light blue is the server pushing action. So it starts before that, and then only after parts of the index HTML are in and they're starting to get parsed, then the other resources will be requested just in without server push in a regular way. So is it better to load a page with server push? Is it faster? Well, yes and no. You can save loading time if you are careful what to push. If you're careful with what you push. If you push too much, if you push resources and images that are not needed by the web page, then, well, yeah, it's a waste of bandwidth, of course. And then it may actually hurt performance. So you really have to think about when to use server push, and if you are not doing it right, then you will be worse off. Yeah, we saw that example. And also, what about caching? What if something is already in cache at the client side and you push it? Then that's also a waste of bandwidth. Well, there are two ways to deal with that. First, in a protocol, what actually happens, just a bit more detail, we have an HTML file once again. Yes, we know. And the HTML file comes back. And then before the server just pushes the resource it thinks that the browser needs, it will first send ahead a push promise. It will somehow show the make its intentions to push clear to the client. And then the client will look up in its browser, well, I already have the CSS file and it's still valid, so no, thank you. I don't want it, just go do something else. So that's one way. And another way is also, like I just showed you, that really simple push implementation. Or you can, of course, make all sorts of intelligent implementations to sort of make that side sort of cache aware or something like that, if that's what you want. But also, you can just set up the push algorithm, the implementation, to only push resources that are, well, hard to cache anyway, that are very much likely to change, to be invalidated in the client's cache already. So I showed you a lot of things that are different with HTTP 2, and it will have impact on the way you develop your web apps. I will give you some additional ideas to think about when you want to start learning about HTTP 2 or want to start playing around with it. First of all, TLS. HTTP 2, TLS is about secure connections, and it's sometimes referred to as SSL, its predecessor. But for the HTTP 2 protocol specification, a secure connection is not mandatory. Though all browsers have decided that they require a safe connection for a secure connection for HTTP 2 to work. So you will always see HTTPS in the address bar of your browser whenever you're on an HTTP 2 enabled web page. So this means key stores, certificates, self-signed certificates. And if you don't know your way around that, then maybe it's a good idea to get up to speed with the basics. And in this time and age, of course, it's not really absurd to master some security basics. We've also had a good talk about that earlier. And with HTTP 2, you may be even forced to know a bit more about that. So don't be surprised, I warned you. And also for the security part, if you would like to use HTTP 2 in a Java application, you need an additional extension on TLS, which is ALPN, Application Layer Protocol Negotiation. But this is basically just a jar file. You need to get the right version for your JVM, and you basically just need to drop it in the boot directory of your Java installation. You just need to boot that up with your JVM. It's not hard, but don't forget it. For Java 8, you need it. But with Java 9, once we have Java 9, ALPN support will be built in, so you don't need to do that anymore. That's just for now. The best practices. In front-end web developing, we have some best practices. For example, resource inlining and image consolidation. And these were designed for and very important with HTTP 1 communication, where a request was more expensive than it is with HTTP 2. But these best practices, some best practices may actually hurt the performance when used with HTTP 2. For example, it may hurt the cache efficiency. You just need to keep that in mind when you're switching an existing website from HTTP1 to HTTP2. Or, of course, when designing a whole new page. I will give you an example with resource inlining. Resource inlining, to the left we have just a basic index, very basic index.html, and it references 3 external files. A style sheet, an image, and a JavaScript. And this is the not inline version. And when you inline this index.html, all the files are actually embedded in one index file. So it has no external references to other files. It's just one big index.html file. Without the resource inlining, it would take 4 requests to load all this to the client. And with the inline version, it would only take 1 request because it's just one big file. You have everything there. But the problem with the inlining is the caching. You're basically caching one big file, and whenever one small thing changes in either of the the embedded resources, then you have to invalidate the file and you have to make the client re-download the whole file. And when you don't use inlining, you can cache various smaller files. And if one file changes, then you just have the client re-download that small file. This was, with HTTP1, that was just a trade-off. You wanted to have not too many requests, so resource inlining was the better practice. But with HTTP2, requests are not that expensive anymore. So in this case, it's actually better to not do the resource inlining and just use the various smaller files. So that's just an example with a best practice. Then the tooling. Since HTTP2 is a binary protocol, debugging is not as straightforward. Not unless you are some genius robot from the future. You need some extra help. Well, I already showed you the Chrome developer tools and the network tab, but you can also, in Google Chrome, you can also view the HTTP2 frames live in a readable form. And it's called Chrome's Net Internals. It doesn't look that fancy, but it's really functional. Here you can view the HTTP2 frames just live, just built in when you have Chrome installed. Chrome browser. And you can just go there by simply pointing your browser to this address. And there's also, as you can see on the left side, there's also a lot of other interesting information there. If you like to use tools like Wireshark and curl, you can. And also with HTTP2. You may have to do some configuration regarding the security keys. And that goes for both Wireshark and curl. But that changes from version to version. So just update to the most recent version and you will be almost ready to go out of the box with HTTP2. So in short, just check your tooling and maybe see if there's some additional new tooling available that really works with HTTP2 out of the box. Because it may not work directly. You may have to do some security configuration. So before giving you some additional information and some links that I do not want to keep from you, I will do a short recap. I started off with how HTTP 1 was not designed for the web as it is today. I told you about HTTP 2's new stuff, about its main new features that I think you should know about. I told you about multiplexing. I showed you how HTTP 1 connections were sequential and how it works with HTTP 2, that multiple requests to the server can be outstanding on the line, and also that the server can send responses whenever it is ready with rendering these parsing these responses. So several HTTP packages may be in transit at the same time over only one connection. I explained server push to you. I gave you an example of a Jetty implementation. Also that HTTP2 is a binary protocol. I explained header compression with HBAC to you, and I told you about stream prioritization and what streams are. Streams are a bidirectional sequence of frames over one connection, and they have their own stream ID. And they also help with the whole multiplexing. What does this mean for you? Well, TLS, security, self-signed certificates. For Java 8, you need ALPN. I told you about best practices, and I showed you an example with resource inlining. And I also told you a little bit about extra tools, for example, Chrome's net internals. Before leaving you or giving you the opportunity to ask me questions, this is a GitLab repo where you can find the example that I showed to you. And you can also, well, just grab the code and maybe build your own more interesting server push implementation there. You need to do some configuration for it to work, but I also included a README file with all the links. But it's basically, you have to download a Jetty server standalone version. You have to enable some HTTP2 and SSL modules. And of course, you need, once again, the ALPN. Then some links I do not want to keep from you. First is a list that is kept up to date by the community. It's a list of known implementations of HTTP2 for browsers. But as I said already, most browsers support HTTP2 properly, and also the pushing, the server push option. But also the server-side implementations that are already there for HTTP2 and also for server push and other options, other new features of HTTP2. So there you can see which servers already support these new features. Then there's another Jetty push demonstration demo. It's a code base from Simon Bordet. He's also Jetty contributor, and this example works with Jetty's push in, with Jetty's own push algorithm, with this built-in algorithm. It's also very interesting to see because it's already, well, more enhanced than my example that I just hard-coded for demonstration purposes. Also really nice to play around, and it works with an embedded Jetty server. So that makes for a bit of a quicker setup. But for me, it was harder to find a way to set up my own server push algorithm. But you can just check that out. And then it's a book. You can read it online. And I already pointed the URL to the HTTP2 section. It's a lot of information, not only about HTTP2, but about HTTP in general and all the underlying protocols. And it's from Ilya Grigorik. It's an O'Reilly book. It's called High Performance Browser Networking. It's also a nice read. It's for free online. So you can, if you have questions later on, or if you run into trouble with the examples or whatever, you can drop me an email, or you can find me on Twitter. But this was what I wanted to tell you. And let me know if you have any questions already. Yes.
A question about the server push.
Yes.
Does the browser keep the connection open so you can the server can send updated resources later?
Okay, so the question is, when you do server push, can the server keep open the connection, right? So that it can send resources, updated resources later on.
Yeah.
Well, that sounds a bit like WebSockets, maybe.
Yes.
Yeah, that's what you were going for. Well, technically, when you read through the HTTP2 specification, in theory, it would be possible to have fully bidirectional communication over the HTTP2 protocol, sort of what WebSockets does. But currently, there's no implementation for that, no. So, but there is an RFC open to have WebSockets on top of HTTP2. It's not supported yet. For now, you have to open an extra HTTP1 connection and then put WebSockets on top of that. So, yeah, to the left.
What I'd like to ask about is, it's been quite some while that people also in the committee is talking about releasing an HTTP protocol, and there has been Speedy and other attempts by Google as well.
Yeah.
But I'm really skeptical about what will actually, what will we be able to gain at the end of migrating to HTTP2? Because what HTTP2 is telling, forget all of, I mean, you're trying to replace an entire client and server architecture in a totally backward, incompatible manner. Because the browsers need to be HTTP2 compatible, the servers needs to be HTTP2 compatible. Okay, but at the end of the game, what do I gain? It's like 10%, 5%, or 20% increase in the overall? Because there has been benchmarks as well. You probably know better than I do. So like there are questions that are raised whether this is something good or bad, because you are trying to replace an entire stack with totally incompatible protocol, and the promises that are being granted are under question. So do you have any practical experiences with this? Like we were working with a client and we deployed HTTP2, and at the end of the day, without doing anything, then the performance increased 20%. So that was one part of my question. And this also, sorry, by the way, I don't want this has been something really bugging me, because when you also go to local JS meetups in the Netherlands, like in Utrecht or in Amsterdam,
Yeah.
there's a hype like Webpack, resource bundling and resource inlining. So this is really a big paradigm shift, and I'm questioning the worth of this. Like, what will I be able to gain at the end of it?
So that's just, to me, it sounds like one question, right?
Yeah. Like
Just like,
how much performance will I gain by throwing out all my code base and and I'm enforcing all my users to migrate to a new browser?
I'm just wondering, why would you think that it's totally incompatible, and why would you have to throw out all your code base?
Because if you have an HTTP2 server, I cannot visit your website with my HTTP1 browser.
Well, most browsers support both protocols, so
We even need to support Internet Explorer 8. So
so yeah. Yeah, that's a problem. Yeah, there are some companies indeed where you still have that. Yeah, and that's going to be a problem, because then it's not backwards compatible. You need a new browser, and they support most HTTP2 actions, and also most HTTP2. Well, the main features that I talked about. But when you're on Internet Explorer 8, and you would like to use HTTP2, then yes, it's hard, and you may have to indeed think about what the cost will be to migrate it all. And maybe it's not worth it.
Can I say something about that? You mentioned ALPN, that's an application layer protocol negotiation protocol. So you can set up a server that supports both protocols. It tries to set up an HTTP2 connection. If it doesn't work, Internet Explorer 8 for example, it doesn't respond properly, it just sets up an HTTP 1.1 connection, and it talks over that protocol
Yeah.
So,
Yeah, that is correct, but in that case,
Yeah.
it becomes slower than HTTP1.
yeah, that's true. You need to maintain either 2 forks of your application or just accept that it's slow. Yeah.
Yeah. Or just do the whole Internet Explorer 8 migration. So I saw another person with a question as well. Yeah.
Can the server push also be turned off on the client side?
Well, that's a good question because I'm not sure. No, currently I think most browsers just accept the server push.
I can imagine that there is some security risk on that one. But
Yeah, but well, but for example, the browser can also always just decline the push intention and decide not to make use of the server push action. But I'm not sure if it's really an active setting in any browser that I know of. No. Yeah, in the back.
You mentioned push promise, which prevents pushing already cached files. Is that something which works automatically, or do we need to do something with that?
You mean the slide I had about the push promise frame sent, and then the browser seeing, well, I have this already in cache, do not push it. Yeah, that goes automatically. That's just how browsers handle the whole server push mechanism. Yeah.
Where's the first version of IE that handles HTTP2?
Well, I don't know by heart. Well, after 8, but but I think it is. I'm afraid it's 10. So yeah. But you can the link I showed you earlier. Would you like to see it again? There you can see there you have a list of all the. Please, can you? Yes. Yeah. On top of that link, there's a list of all the implementations and also for the browsers, and there you can see which versions or which browsers support which functionality of HTTP2. Yeah.
You mentioned that Jetty already comes shipped with its own implementation of the server push,
Yeah.
which is kind of more elaborate. Was wondering how it does figure out which resources are worth advertising for the server push.
Well, there are lots of parties working on interesting ways of well, finding out what to push and what not to push. Basically, what Jetty's own implementation does is when you first request a page, then it looks through through the request data, and then it'll sort of remember, it'll cache what resources reference other resources. And then when the page is loaded next, then it pushes these resources. But there are lots of other implementations. Well, you can make your own as well. So it's still not, it's still relatively new. I saw another hand raised. Yeah.
yeah, I was wondering if you would have multiple servers and with a proxy in front of them, or like a load balancer, would you then need to use server pinning to be able to make use of all of these HTTP2 advancements?
Sorry, would you need to?
Use server pinning. So like when server pinning is a technique where a client always connects to the same server via a load balancer.
I don't know about that. I'm sorry. No. I haven't played around with that. No. Yeah.
If you have to compare streaming with chunking, do you consider them to be the same, or is it something entirely different?
If you, sorry.
Chunking and streaming, would that be the same, or is it something entirely different?
I'm not sure if I understand the question. I don't know.
As part of HTTP1 or 101, you can have, let's say, fragmented data streaming in. That's called chunking.
Yeah.
Versus the streaming you mentioned as a new feature.
Yeah.
I'm wondering in comparison of those two, do you consider them to be the same, or is it something entirely different?
Well, it's something entirely different with HTTP2, the whole streaming, because it's also bidirectional. And you can have lots of streams doing independent things on one connection, which are then interleaved and stacked to one multiplexed connection and stream of data. So I think it's a different concept. No hands. Somebody scratching their head. It's not a hand. Yeah.
What about sprites and so on that we use in the websites? For instance, when you go to Google and you want to check the performance of your website, they recommend you to have sprites, like collapsing all the small images in big one image. Because HTTP connection handshake is expensive and so on. But with the HTTP2, this one will be an issue.
Sorry.
Many websites right now on the internet are using sprites.
Yeah.
So how will HTTP2 affect them?
Well, I think I'm not sure if that's a recent recommendation, because yes, the SSL handshake is expensive, but you will only have one connection, and you can multiplex. So it's, well, I'm not sure. I think it's not a. Sorry, I'm not sure if I understood the question correctly. Sorry, just.
Right now, if you want to increase the load time of your web page, what you do is you collapse the images into one big image.
Yeah.
You also mentioned it in one of your slides. So with the HTTP2, you also said that this doesn't need to be necessary anymore.
Yeah.
Because the handshaking is cheap. So do you expect them to split those sprites into multiple images back again? Or you say keeping sprites is still okay?
Well, I'm not sure. I haven't seen any tests with that yet.
Well, I
So.
think the sprite is a form of inlining your data.
Yeah.
So if you use HTTP2, you shouldn't inline your concatenate your images into a sprite. Just use separate images, because you can all push them in one stream. Even multiplex, so interleave. That was your first demo, by the way.
Yeah.
And then it will be faster than with a sprite, when using a sprite, or just a sprite. And you will leverage caching, because if you choose one image, you only have to use.
So.
Thanks.
Okay. Well, if there are no further questions, then I think we have an energy break upcoming. So enjoy a bit of coffee, maybe.